People say I always start off my videos with, okay guys. I didn't. Alright, Pythagorean theorem. Most of you guys have probably heard of it before, seen it before. We're just going to talk about it a little bit, work some examples, and that should be it. Since we are in a unit talking about triangles, I went ahead and added Pythagorean theorem into it so we can talk about everything that's associated with a triangle. First of all, Pythagorean theorem is something that you can use only whenever you have a right triangle, okay? And so you need to understand what you're looking at. A right triangle is a triangle that has one angle that's 90 degrees, and that little box there is always the 90-degree angle. The sides that are not the hypotenuse are called legs. And according to the Pythagorean theorem, the legs are A and B. But you can interchange them. This one could be A, this one could be B, or this one could be B, and this one could be A. It doesn't really matter which one you make a leg, as long as one of them is A, the other one is B, according to this formula here. The issue is, what is the hypotenuse? The hypotenuse is always going to be the hypotenuse. It can't be anything else. And it's always going to be the side diagonally opposite or across from the right angle. So you always know the hypotenuse. The hypotenuse is always the longest side, but you won't be able to always tell by looking. The way you need to find the hypotenuse is by the side that's diagonally opposite of the 90-degree angle. I cannot stress that enough. So basically the Pythagorean theorem says there's a relationship between each leg squared and added together. It equals the hypotenuse squared. Alright? And so in a right triangle, the square of the length of the hypotenuse, the square, meaning to the second power of the length, how long it is equal to the sum, meaning adding, of the squares of the lengths of the legs. So in plain English, this equation right here holds true. C squared equals A squared plus B squared. Or most of the time, it's A squared plus B squared equals C squared. But it doesn't matter the order as far as what side each one of these are on. A and B are always the legs. C is the hypotenuse. Hypotenuse is always the longest side. And the triangle must be a right triangle. Use this theorem. Alright? With that in mind, I'm going to take this and slide that over. And now let's work an example. Notice that on this particular problem, number 1, I don't know what AB is. I want to find AB. Notice that AB is the hypotenuse because it's diagonally opposite. So I'm going to set up 20 squared plus 21 squared equals C squared. It's very important that you designate which one is C squared and what you're trying to find, because a lot of times people mess up in Pythagorean theorem just substituting stuff in and not sure. Now, just for the record, it doesn't matter if you did this as well. 21 squared plus 20 squared equals C squared. Either one of those could be A or B. Alright, but let's just stick with this one right here. 21 squared, 20 squared, and all that good stuff. So you get a calculator. I don't want to mess up and y'all be laughing at me. So, yeah, I knew that. 400 plus 441 equals C squared. Alright? So now I add those two together and I get 841 equals C squared. But the issue is I don't want C squared. I want C. So how do you get rid of that 2? Does anybody know how you get rid of that 2? Well, just in case you don't know, we're going to use and I don't have my, okay, I'll use this one. We're going to use the square root. The square root makes that 2 go away to a 1. But if you do it to this side, you also have to do the same thing to the other side. Now, what you would do is, hopefully you got a scientific calculator like this, and I'm going to do the square root of 841, and that equals 29. So it's a perfect square, all right? So what that means is C equals 29, or this side right here is 29 units. Normally you would say plus or minus, but we won't worry about that in geometry. All right, let's keep going. This next example, number 2. Notice here in number 2, I am not looking for an hypotenuse. I know my hypotenuse. So I'm not going to be looking for C like I was up here. On this one, I'm going to set it up as 8 squared plus x squared equals 20 squared. I don't know what that is. So even if they don't give me a blank like they did on the first one, I didn't have a letter there, I'm going to put something in its place like c squared or b squared or whatever. If you're missing one, you can use x. It doesn't matter. Now, how do you solve for x? Well, go ahead and simplify. 64 equals 400 plus x squared, right? You subtract 64. What are you doing? You're solving for x squared. So 400 minus 64 is 336. Now, again, you take the square root to get rid of that 2. We got to get rid of that 2. And how you do that is to take the square root. I don't know if you can see that. I can barely see that. So you take the square root of both sides. And then notice what you get here. You get x equals, when you put that in your calculator, the square root of 336, you get 4 radical or 4 square root of 21. This is the simplified version of 336. You guys need to be able to use a calculator, and all I did was put the square root of that in. Now, what if I asked you to round to the nearest tenth or something like that? What you would do is you would hit the button on top of enter, which is this button here, and notice that it gives me a decimal. And if I want to go back, I hit it again. So that button right there helps me go back and forth. So as a decimal, this would be, and this means approximately equals 18.3. Okay? But you need to read your instructions to know which one you're going to do. Simplify radical form or to a decimal. Let's say round to the nearest tenth or 100th or something to that nature. All right? That's just how to use the Pythagorean theorem, finding one of the legs on number 2 and the hypotenuse on number 1. This is something that you need to take notes on. It's out of the book, but most places are going to have it. And it's basically a way to tell if you got an obtuse triangle or an acute triangle. You think you can tell by looking, but sometimes you won't have a triangle to look at. You will have just numbers. And so what this is basically saying, you might want to pause this and so you can get it down. But what this is basically saying is if you do a squared plus b squared equals c squared, and the both sides are not equal, and if the c squared side is bigger, then the triangle is obtuse. If the c squared is smaller than the other side, or the a squared plus b squared side is bigger, then a triangle is acute. So what I like to do is just look at c squared. If a squared plus b squared equals c squared, then the numbers you have is a right triangle. Okay? If it actually equals each other, if both sides of the equation equal each other, then it's a right triangle. If the c squared is bigger, then, and c is always going to be the bigger number, then it is obtuse. If c squared is smaller, then it's going to be acute. And let me show you examples of that. Let's look at number 27 and 30. How about that? 27 and 30. We got 4, 5, 6. Call this example 3. We got 4, 5, and 6. And we want to know if this is acute, right, or obtuse. So we need to find out. You know how you find out? You take the smaller numbers and you square them and add them together. Remember, the hypotenuse is always going to be whichever one's the biggest. So C is always going to be the biggest one. It doesn't matter which one is A or B, but C is always going to be the biggest one. 16 plus 25 equals 36. Is this a true statement? What's 16 plus 25? Is that like 41? I don't know. I can't add right now. It's the end of the day. I have done all the math. Yeah, I was right. All right. So this is not a true statement. 41 does not equal 36. But notice that this side is smaller than that side. So what that means is these numbers represent an acute triangle. Because this side, the a squared plus b squared side, was bigger than the c squared side. Now, number 30 gave us the square root of 3, 2, and 3. All right, so we're going to do the square root of 3, squared plus 2 squared equals 3 squared. So this is, when you square that, if you put that in your calculator, it'll give you 3. Plus 4 equals 9. So that's 7, which does not equal 9. And so what you really could say is 7 is less than 9, which you don't really have to do that. You can see which side is bigger. And since the c squared side is bigger, what that means is this is an obtuse triangle. Again, if you got 7 equals 7, 9 equals 9, or over here you got 36 equals 36, or 41 equals 42, then you would say it was a right triangle, because if it equals, it fulfills the Pythagorean theorem. And so this is just another way for you to figure out right, acute, and obtuse. Alright, this is just a short intro to Pythagorean theorem and a little bit with simplifying radicals. Peace.